Okay, good. Okay, welcome. Okay, today's class we will talk about class templates. Okay, so we'll just start with why it's required. Okay, so why class templates are required is to reduce the amount of code that we write. Okay, so we can just write a small template. Okay, a class template and tell the compiler to introduce or rewrite the code for us. Okay, it is like instead of you writing, you are asking the compiler to create the code for yourself. Okay, so that will just reduce the number of lines of code, and the most of the repeated code that you write will be eliminated. Okay, so assume in this class we just wanted to create a array class. Okay, which will create an array of integers. So it's like it will just create an array of integers on heap. So we can actually do that like this also. Int array of 5. Okay. So only thing is this is created on heap. Okay, all these are objects are created. I mean, this all these objects are created on stack. Okay. So if you want to create them on heap, we can do it in a different way. So you can put a pointer and say new uh, int of 5. Okay, we can do it this way as well. Okay, but we want to reduce it, like we don't want to do it. Okay, we want a class to do it. We want a class to do it, and we want some additional functionalities on top of it. Okay, once you create it, right, how do you print it? Like you would like to do something like uh, a print function, print content function, which will take array of it, and it should uh, print it. It should print the entries of it. Okay, so for this you need to write this, and you need to pass the array, and you need to pass the size 5. Okay, so what if we can write a code wherein the we don't need to rewrite this for each and every data type. Okay, so as you want to do it for char. Okay, you need to declare a char here, and again you need to write a function which will take characters as input, and again the size of it as an argument, and it will print the contents. Okay, that's a repetitive code. Okay, the more entries that you data types that you have, you would repeat the code. What if you don't want to write the code? Can we uh, do it in any other way? Okay, so we can declare something like a class template. So what is class template? How do we do it? So class template is nothing but so first thing you would just write a class. On top of it, you say this class is a template. This class is a template, and you pass an arguments by name class and the type. Okay, actually you can pass more than one argument here. Okay, but for us, for this example, we'll say we'll just pass one type. So we'll just pass one type here, and whatever that we did here, right, initially, here we'll do this internally. Okay, so this takes type T. Okay, now this type T can be replaced inside your class wherever you have a repeated part. Assume temporarily I'm gonna comment this. Okay, so let's write a class, array class it, which will just create uh, array of ints, and you can write a print function which will print it. So here you're going to have a int pointer, integer pointer, and for this pointer you're going to initialize with by creating objects on heap. Okay, int, and you're gonna pass the length. So the length is nothing but the size that you want to pass. Okay, so you write a constructor which takes number of elements to build. Okay, and you store the size that you passed, okay, internally in this variable. Okay, then you just create the as many elements as you want on the heap, and you can initialize it to whatever type that we want. Okay, so this is a code that you don't need to write here, you can avoid. So you would have some initializing code here, and some printing code, and some printing code
So,
you will have here.
so
Yeah,
that is
yeah,
the syntax of this class template, right?
yeah.
So,
This is a syntax. Okay, assume
okay.
I have, as of now I have commented it. Okay,
Mm-hmm.
so you
Mm-hmm.
I am creating a array class which will just create only ints. So here we will have int and int. Okay,
Okay.
now I want to
Okay.
create a array of character classes. Array of character
Mm-hmm.
classes. What it will do here, you will go and make a change, like you will make it char, and you will make this char.
Means we can go for any type of class. That is not an
Correct.
issue. Means
So
right
you
now we
can,
are going for the only array class.
correct.
Yeah.
Okay. So array of ints. Now I made it as array of characters. Okay. Now you want to generalize this. Okay. See, you want to create an two types. Okay. Array underscore int. Okay. Now array underscore char. This was my repetitive code. Okay. This was my code. Here, using this class, I can create array of integers. Okay. Using this class, I can create array of integers. And using this class, I can create array of characters. Now, if you see this section and on the section on top, everything is same. There is no difference apart from the this type. Okay. Now, how do you want to
Yes.
minimize? This is a repeated code, right? Nothing else you are doing. So this and this are not derived. Okay, this and this are not derived. Okay, they are completely independent. Now you want to reduce the number of lines that you want to write. So what is common here? The data, two elements that here and here are common. So we extract it and make it and look like an abstract. Okay, so that's where the class templates comes in here. So you can just copy paste the code that you wanted and generalize this name. Now it is just a array class. Okay, and it takes one type, type one. Okay, and it is going to be, it is, this section will be replaced wherever you see repeated section in your class, right? You can just replace it with this t and t. Okay, t and t. Now I'll tell you what is this t and t. Okay, so this is a section which is a replaceable section. It is like macros, like you can replace x with y, like whenever you write min and max, right? Okay, and you can replace them during compile time. The compiler will replace it. Okay, so now array class is declared like this, like a template. Okay, now how, when will the compiler introduce a class of a type that you want? So this is just a template. Now you just defined a template, but you are not using it as of now. So when will you use it? So whenever you want to use it, let it be in your main. Okay, you can declare it and pass first argument, okay, of the type that you want. So here my type is what? Integer. Okay, here my type is what? Integer. Since my type is integer, here the t will be replaced with int. So wherever it sees t, capital T, it will replace it with int. Okay, int and int. So this happens during the pre-processing type. phase. Okay, during the pre-processing phase it happens. Okay, now can I just create int? You can create something of type double also. Okay, obj, and you can give a name objd. You can make it char also. So with this, see, now you see the code is very simple. So what it will internally do, it will create an array of
Of
5 and
integer type.
of integer type. Here he's going to create an array of doubles and char.
Mm.
Now
Mm.
inside the constructor itself, what we are doing, we are doing mallocing and initializing it to some random values. Okay, we are initializing it to some random values. Sorry, here we are initializing it to some random values. So we'll just comment this part of the code is no longer required for us. Okay, here we're initializing and it will build in. Let's compile and build it and see what just happens here. Okay, just compile. So it just printed 0 1 2 3 4 0 1 2 3 4, and here you see an empty line. Okay, why is it? Because we created an array of characters. We created an array of characters and initialize the contents with 1 to 5. Okay, so the ASCII value of 1 2 3, they are non-printable characters. So it is just occupying space, but you cannot see it. Okay, you cannot actually see them. So that's why. So maybe we can do something. We can just put 30 plus. So if we make it 30 plus and compile, then we can see 30 plus means, okay,
Okay, okay.
yeah, we are getting, but 30 30 34, we are getting, it is printing it in a type that it wants. Okay, it is printing, it is treating it as int because you made it 30 plus ptr, it is of type something else, right? We'll typecast it to a type of what we want. Okay, we'll just typecast it and see if it is doable or not. It got printed. See, now it printed the actual strings. Now let's see if what is the ASCII values. ASCII value, ASCII table will open so that ASCII table. What are the printable characters? They start with
65.
30. Yeah, no, that is
65.
decimal value.
Mm-hmm.
For us, agree. To 65 will give capital letters. We can simply put 40 also. We can put 97. So okay, we'll put 65 and see. We'll put 65 and see. Okay, what happens? So it just gave A, B, C, D, E. Okay, 5. 5 on top, 5 on bottom. Okay, because these are ints, these are doubles. Okay.
Hmm.
So
But
y-
a 65, it is calculated as a 65, 66, 67, like that.
yeah. So
Yeah.
we created, right, 65. So 65 plus index, 65 plus 1, 65 plus 2, 65 plus 3. That's what we did. So here okay, we should have done it here, I
Hello.
think. Yeah.
That after that we created that that was not audible after that. What you said.
Okay. Which one, right? We made it ASCII, right? Hey, Sakalya, back. Okay.
Yes, yes, yes.
Okay.
Why
Okay.
it is happening? And sometimes breaking.
I don't know, man. This Airtel, sometimes this happens. I'm in a different room. Router is in different room.
Okay, okay, okay.
Maybe the cable that I've used. It's a Unix PC, Linux PC, right? I think I can't
Hmm.
control certain things. Okay. So
Okay.
your question was, okay, we'll remove this here, this typecasting also, because we'll remove this here. So we just added 65 here. So
Mm-hmm.
when creating itself, we just added 65. Let's not do a typecasting. We'll see what happens. So it just printed. Okay. So here what we did was we were printing 65 plus something. Okay. The result was printed. Okay. But the contents were not edited. So, but when creating itself, if you add the 65 or some number, the contents will remain same. You don't need to typecast when printing. Okay. So,
Mm-hmm.
so this part you understood, right? So you can have T and you can replace it whenever you want.
Yes, yes, yes.
Okay.
Means
And
for different data type, different things
things
need
that
to
you
be right here.
correct. So similarly, you can give more than one argument. Okay. So you can have, see, if you see here, int is there. You can also pass one more argument here. Class, okay, x t t u. Okay. After t, you can give u, and you can replace it with u here. Okay. So for u, wherever you see int, we can make it u. Okay. Now, since you are passing two arguments here, you can also give two arguments here. But why we are using that second one? It is just for indexing, right? So indexing, you can make it int. Okay. You can make it something like a size t or a double or anything. Okay. You can pass more than one argument. See here, both arguments are int. Here one argument is double, other argument is int. So double or int or char is where these are your primary data types where you store your actual data. Whereas this int is just used for your storing the max size. Okay, my max size can be max int size. Okay, you can make it size also. Like you can make it something like 8 byte content where you can store larger numbers also. Okay, now we can compile this. Okay, and see the result will also be same. Okay,
Okay.
am I clear on
Means
this?
how it will be same there? Means you
Okay,
have changed to another one, right? Length
so
also changed.
the length
Mm-hmm.
I made it as u.
Mm-hmm.
Here it was int, I just made it as u. Okay, so u is a second parameter for this template. The template takes how many parameter? Parameter 1, parameter 2, and we are passing the parameter here, int and
Mm-hmm.
int, double and double,
Mm-hmm.
double and double. So on the second, whatever you sent, right, this is your u is int everywhere.
Mm-hmm.
Okay, So this u, wherever it sees u, it just replace it with int. Okay.
Okay.
You can replace it with anything else. So this one way you can do. Generally, second parameter can be used for something else also. You, now I can make it v.
Only we can change the data type, right? Using
Yeah,
these parameters.
yeah. You can change the
Yeah.
data type, or also you can typecast it here. So here I can make it v. Okay.
Okay.
Now I can pass it. So earlier we saw, right, our results
Mm.
were 65 and ABCD. Okay.
Mm-hmm.
Now we
Yes.
can
Yes.
make it okay as we want. Okay. I can, instead of printing ASCII values, I can print int values. Okay. Now the third
Mm.
argument is v.
V.
Okay. Now let me pass. I want to print my results as int. Okay. Is it doable? Okay. Now see, it just printed everything as int. Why?
Done.
Because we wrote a code wherein when you are doing C out, okay,
Mm.
it is just typecasting everything to something else. Okay. Now I can make this int as char and see if it accepts. Because char is
Mm-hmm.
smaller conversion, right? Down conversion. Whether it is doable or
Mm-hmm.
not, we'll see what it does. See, now it just
Yes.
printed everything as A, B, C,
Character.
D.
Yeah.
Okay, this is all we can make. Okay, now you can pass this as here double, only one of them as double, and see what the second entry as double, and see what it prints.
Mm.
So just
Yes.
printing as it is, because it's
Correct.
a pure this value, it is not printing the floating values. Let's see, can we make it float? So it is
Point
not,
zero, point zero.
it's not
Same thing.
coming
It is.
because it
Yeah.
doesn't have any points, so it is not coming as
Yes.
point.
Yes.
Okay. So this is how we can use the class
Means
templates here.
means now you have done that implicit one, eh? Implicit type clustering. That
Correct.
explicit if you'll do, then it will be might be different or
No, this is explicit.
yes.
This is explicit conversion, right? We said
uh,
this should be converted to this. Implicit means it is compiler will add. You will not type anything here. I typed V
okay.
here, right?
Yeah. You did that maximum to means lower one.
So here what we did is we did explicit conversion. We didn't do the static
Mm-hmm.
conversion.
Okay. Okay.
That is re-enter cast you are trying to say, right?
Mm-hmm.
So that we can try and see whether this is doable. Static cast. Static cast into V and see what happens. See, it found, it didn't see any issues. Okay, it does. From double, from whatever type
Same
basic,
thing. It is coming. Same thing. It is
you
coming.
don't see any issues. Yeah, so
Mm-hmm.
far it didn't find any issues. So we can do all the conversions that we want. Yeah. So it's generally used for replacement. So okay, any doubts on this?
Yeah,
Okay.
that's fine.
Okay, next we'll see what is there in this class template. Because I have few examples related to linked list and all that I have implemented. We can go through that because most of your questions on this will be on creating a stack or something like that. They'll ask you to create a stack. So write your own stack, okay, or a linked list
Mm-hmm.
is what they would ask you to do. Okay.
Mm-hmm.
So what does stack is? What would you do a stack? So how can you write a stack class? So these is going to be our questions, interview question, most common interview questions that you want to have. Okay, I'll save this. Okay, so first thing, that you should always do is, okay, no, and many examples here. Okay, so I can have a stack class. Okay, so before getting into creating a stack class, right, we'll just create a stack of hints. Okay, then we'll see wherever we are repeating how we can avoid. Okay, is my, I will rename it stack of hints. So first we'll write a class as it is. Okay, then we'll remove the data type associated with it, and make it a class template. Okay, so what does a stack mean? Stack is something, it is an array of fixed size on which you add at the top and remove from the bottom. Okay, on which you add from the top and remove from the bottom. Okay, so what does it mean? Statement one, array of fixed size. Okay, so let's, for an this thing, right, we'll create an array of this thing. So my array can have a max size. We'll define it. Okay, is equal to 10. Okay, so it is going to create an array of size 10. Okay, now how you can achieve adding or removing elements into it is by using methods by name push and pop. Okay, you just need to have functions by name push and pop. So let's remove all this. Push, what you will do, you will take some int value. Okay, you're going to take an integer because it is of type integer. You would take this and add it on top of it. So what you will do, you are going to just add the content. So we can say top, which is initialized to 0. Okay, so array of top is equal to x. So I'm just going to copy the content to the top, and then I should increment it. So I can just say plus plus. So it is just on top you are copying the content. I'm just going to increment it. Okay. So you can write a safety check here saying that if top is equal to max size, return. Okay. So you don't do anything. If top has reached, I mean your index pointer has reached the top, just return. Don't do anything. Okay, that's what we can say. Okay. Now pushing means you get you will get a content and you're going to add it. Now the other function that is associated with the stack is pop. What you will do in the pop, okay, or you can have a function by name top, or you can write pop itself. Okay, what it does, it takes no parameter. Okay, but it will take the contents from array and will return it. Okay, and it can return it. Okay, so before doing that, top should check whether he is already pointing to the bottom. Okay, if he is pointing to the bottom, if bottom means 0 in your array, if it is pointing to the location on top, it is going to return. Okay, some error. Okay, we can say it as -1 for us temporarily. Okay, now he is going to return array card top, and then what he will do, he will just decrement it. So this is the most of the code is going to be push pop. Then you can write some more function is like something like top. Okay, some primitive checks and all you can write, whether if top is pointing to index x, y, or z, or a lot of validations that you can write, but I don't want to get into all the validations. Okay, so this is your simple stack. Okay, now how do I make it a class template? My question is, how do I make it a class template? You just remove the okay, you just remove the what is it, the data type that we have strictly associated with it. Okay, so before doing that, we can take a test of this, whether this guy itself is fine, working fine or not. Okay, let's comment this part. So I just created an stack of int. Okay, so what can I do in this? I can push elements and pop them. So I can for let a for loop int I is equal to 0 comma I less than max underscore size.
Or else you can do that pull push, means from top side you can pull
Yeah, that's what I'm
and
going to.
bottom side you can push it.
Yeah, correct.
Yeah.
So I'm going to do that itself. So what I will do,
Mhm.
dot push. I'm going to push, but I need to iterate, right? How many entries are there? Every elements I need to fill.
Yeah.
Okay. Next I'm going to do a pop.
Mhm.
Okay, as many entries are there, I'm going to do it. Here when pushing, I'll pass the index I. Okay. While popping, I will print whatever content that is stored into it. I'll print it. So I can make it some displacement also. 30 plus I can just say 30, 31, 32, something like that. Or let's stick to 65 so that for ASCII values we can make it as a printable item. Okay. Now let's stack class. Let's compile this. I'm going to compile it. I got an output. So where is it? Ah, I think it just printed here 9745666 something like this. Let's wait. I didn't add any handles. Okay. So what did he add? 65 plus I. Okay, 65 plus I, 65 plus I. What is the value of I? It should be 0. Okay, 65 plus I. Where is my 65? Somewhere something went wrong. Okay, in popping it went wrong. Pop.
So you did push also that 65, right? 65.
Okay. You are able to hear me, right?
Yes, yes.
Okay. So I did wait. Okay. I did push with 65 plus. Agreed. So while popping, I think the index somewhere I'm going a bit ahead. So that's the reason it is giving us some error. Top is equal to, okay, top is equal to -1. This should be my prob. Okay. See what happens now. 66, 67. So when popping, I did -9. Maybe this should not be equal to, or this should be, actually this should be less than. It should be greater than or equal to. I think some. Am I putting
Same thing,
more?
it is coming.
Am I putting more entries is what I'm trying to see. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It is 10.
Mm.
So it should be first in, last out. Okay, now what was entered into the last?
So in the main function also that integer should be greater than on the max size.
Int is
Here.
equal to 0, int less than max is 1, right? 9 entries. From 0,
Mm,
you are going to enter. It should start with 65.
mhm.
65, 0 to 9. 9 entries we are adding. 65 plus 4.
Okay.
75 it should come. But it became 65 plus I. Why is it?
60 plus.
Does it have anything to do with merge?
Means it is working as a last in, first out.
Huh. That is
Yeah,
our
last
implementation. It should work like
fast.
that only. That is what LIFO is all about, right? It should mean stack means that is what it is.
Last in means 66. It has happened 65 plus 1.
75 should come at the top actually, but it is, or when pushing itself, it is adding one more and incrementing and adding 65 plus I. I is initialized to 0, but somehow I is becoming 1. Okay, we'll remove the 65 itself and see. Okay, 9998. Okay, we might have added. Why is it not starting with 0? Int I is equal to 0. Okay, maybe we are doing something wrong with the pop itself. It would have added here something. Okay, not post increment. We should do pre increment. Okay, now it is fine. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we'll add 65 here. 65 plus I. We're doing some increment or something wrong in the increment and decrement part. So 65, 66. Okay, that's fine. So this is how we just simply implement a stack. Okay. Now we will remove the strict binding for data type here. So how we can do is we'll just copy this. We'll comment this. Okay. We'll just remove this and declare something like template of class and T. Okay. So wherever we had that strict binding. So now what we want, an array. It's an array. So this array can be typecasted to T. We will just replace the data type of this array to T. Okay. Now this top can be integer. Okay, it doesn't matter for us. Okay. Now when you do a push, what you should get? You should get data of same type. You get
T of
data of,
x. Yes.
it will be just T. Okay.
T of x. Yes.
T and you will get X. And top doesn't matter, max size doesn't matter, rest and all also doesn't matter. Now, but when you return, should it be int? No, it should be the actual data type. Okay, so we can replace it with T. Okay, now this is your stack. Now let's create data of that type. We'll create stack of int and we can give a name s underscore int. Okay, so your stack of ints are created. Okay, and you can write the rest of the code remains same. You don't need to do anything more here. So the behavior
Here we
undergoes.
no need to change that data type to T.
Yeah, this is your application, right? Okay, here
Yes.
you can't write T.
And
Here you
yeah,
can't
yeah.
write
That
T,
is
right?
only me. Yes.
In the template you can write. Here you should know what you are doing it.
Only inside the class, whatever you want, you can change. Yeah.
That we can. So now
Hmm.
we can replace this with int chars. Okay. Okay, now it is going to create an stack of chars.
Yes.
Okay. Now we're going to push into it and pop from that.
Mhm.
So it is just going to be 2 and 2 results. Okay. 65 to 74 and A to J.
J.
Okay. This is how
Yes.
this is how we can implement them. And you can similarly, as I said, the results also you can change the typecasting part. But here you are printing it, right? So this is part of it. Okay. You can implement the print function here. Void print. What this guy is going to do is he's going to print the complete contents. Okay.
Mhm.
So what I can do is I can do copy this and paste here. Int, int. Here will not do pop. Okay, if you do pop, then we are actually doing something else. Okay, actually, it should not be print. It should be clear. When we do a clear, right, we are popping, and this dot pop. Again, right, this dot pop or not. This is also not required. You can just call a pop. So when you are popping, you are just clearing and removing the item from the top, and you are popping. Okay. Now you can write a initialize function. Okay. You can write a initialize function where you are going to push them with some values. So you can say push. So push, you can remove this thing. So 65 plus I. Okay. Now here you can replace all the types. Here type replacement is also not required because the pop will return the data type. Everything, the return type is implicitly added by the compiler. You can add a specific typecast if you want. I'll show that. Okay, now you can just do initialize and clear. Okay, now you can remove this code and say s underscore init dot
Underscores.
underscore dot init. Okay, and similarly we can say clear.
Clear.
Okay, the same code can be copy pasted here. Okay, on a different data type. Okay, now result should be same. See, it is same. A to J and
Yes.
65 to 74. Okay, now here you can pass second argument char, second argument of any type you want. Okay, and you can ask this to be int. So you can initialize something out of int and print it as char. Similarly, you can initialize something as char and print it as. Now this is the
Int
second argument, right? So you can add a
plus
tu.
U. Mm.
Okay, you can add a capital U. And when printing, where are we printing? Here. We can just do a typecasting. We can ask compiler to typecast for us. Okay. Now result will be up to top. See, the integers that we added at the start.
Oh,
Okay, the integers that we added at the start. Okay, were saved, but when printing, okay, we typecasted them back to characters and printed. Okay. Similarly, characters we added to the stack. Okay, they were remaining as characters, but we wanted to typecast them to int when printing. So we typecasted them back to int and it got printed. Okay, so all these magics, gimmicks we can do with the help of templates. We can reduce the code. You don't need to do the typecasting x to y, y to x, something to something, etc. to etc. and all. We can reduce the code. See, the code is minimal, very minimal here,
oh,
right? You are not doing copy paste, type conversions, etc. etc. and all. You can do it just here. I hope I'm clear on this. So
like mean, see, it is like a type def, like a alias you can use, right?
maybe no. See, the template is not something. It is like you are telling a compiler to replace okay certain things
Mhm.
with certain things. That's all. Now
It
the
is
compiler,
replace of the that data type, but there
yeah,
that
replacement
is
of
whole
data
code
type
will be
or
changed. Mm.
typecasting. It can be data type or you
Mhm.
can typecast. This is a
Mhm.
typecasting to a particular data type. Here also it's a data type that you are trying to change. So it's basically like that only. So you can not just have array of ints, you can create classes. Okay, and you can have a stack of classes also. So you got that right. You can have a stack of
Yes,
classes
yes.
also. Okay. I think in my this thing they have a lot of examples. Okay. So stack we did. Linked list you want to do or you want to do it as a for your practice you want to do this.
I mean,
So linked
you
list
you'll tell or means,
it's there. My
I'm not
code is
getting.
there in the GitHub. Okay.
Okay, okay,
But
yeah.
as a practice you can take it up. Okay. So in
Okay,
my
okay. Then
interview
I'll
prep
try.
I have them. So in my
Mhm.
tree implementations I have, stacks I have, queues I have, linked list I
Mhm.
have, stack
Mhm.
templates. So you can
Oh,
go
same as
through
like stack template only, right? This
stack
linked
template.
list.
It is the same, whatever we
Mm.
did now. Now linked list will
Mhm.
have, the data structure will be a bit different. Okay, there we
Okay.
had an array of ints. Here it's going to be something else. Okay, you're going to have a, first you need to create a structure,
Mm.
okay, of T of object, whatever type. Then
Mm.
it's going to have a next object. What? Okay. Then the rest is like adding, pushing, top is empty, length, reverse the linked list, adding, print all,
Mm.
print from. See if you are able to do this, right, you can go through this and implement it. You just change the name and try to see what best you can do. Then you will actually learn class templates and all. Okay. Okay. I think that's all I
Okay.
wanted to have. Anything else you want me to cover in this? Any doubts with this keywords?
No, it's clear. Means
Okay, good.
this template part, it's clear.
Good
So
man.
I
And
have to go
I
to
think
that linked list one.
yeah,
So.
you try that. Okay, you try if,
Mhm.
and maybe repeat tomorrow. If someone else join, I'll repeat it along with them. So
Yes.
it would be better.
Yeah, yes.
Okay. Thank you. Thank you, Sakalya. If you have any questions, right, can do some exercises and you
Yeah,
can come back. Then we can take it as an activity one for 1 or 2 classes. Post that, I think we'll end and we'll start Linux. Okay. So that should
okay,
be good.
okay,
We'll not
sure.
concentrate on C anymore. Okay.
Mhm. Okay.
Thank you. Thank you, Sakalya. Have a great day.
Thank you. Good night. Yeah.